Hey guys, Oster Collins here. This is the drone model our team is working on. We've used Blender 3D simulator to demonstrate and explain how agricultural drone work. And in this demonstration, we are using quadcopter. That means a drone with 4 arms, and octocopter, a drone with 8 arms, to demonstrate how the drone will work. So here I'm just going to explain to you guys the features of our drone. One is the frame. The frame is what holds the components of the drone, and I'm going to show you the image, and here it is. So here is the frame, and on the frame we have got the components of the drone being placed or being inserted, and here is another one. So for example, here this is octocopter. It has got 8 arms, and this design here is a quadcopter, which is having 4 arms. So another one is we have got the arms, which is here. These ones are the arms, and we also have the motor. This one here, these ones, there are 4, and then we have got the propellers. These ones here, the propellers, these ones, and then the embedded features here means components which are not necessarily the part of the drone, but they are placed so that to perform a specific function. Like here we have got our digital camera. Here, this one here, the work of this digital camera is to take the photos of the plants, and it sends to our database for analysis. This is so much important because it will save farmers a lot of time if they were to go to their farm and monitor the plant physically. It will take them a lot of time. So this camera will be taking photos, and then it sends to our database, and then we'll be able to analyze the leaves so that we can detect the disease earlier, and then we act on what is supposed to be done. And then we have, I'm just going to explain on a few things on how the drone will be working, because I know most of you guys are now asking, actually, how are these guys going to do this thing? But it's just some few simple physics which are not complicated. So here is what we have. We have got the motor. When you apply voltage to the motor rotates, and then the propellers, they rotate, and then after that thrust force is produced. So the thrust force will be able to lift the drone depending on the weight of the drone. This is what I mean. if the weight of that drone, the whole weight of that drone plus all the items, everything, you measure the weight of that drone and you find that it weighs 800 grams, then the thrust that we need to produce so that the drone can be lifted must be 1600 grams or higher than that. So it means that the ratio of weight to thrust is 1 to 2. So with that we'll be able to lift that drone. So we've just explained on very few features of our drone and just few design, and also in our drone we'll be having a water tank which will be able to hold water to do the spraying or to hold the pesticide, to do the spraying in the farm. So here is the water tank, and we also have the pipes and the things which we'll be using to spray, such that when the pressure is exerted on the surface of the pesticide, it will be able to be sprinkled on each and every plant. So this drone will make it to be a smart drone, such that the user will not be doing much of the things, but it will be doing things on its own. So we'll also have transmitters and receivers so that we can know much more things about the drone. When the battery is low, we can detect that and then send to the drone controller or the drone pilot, and then the drone will be able to come back to the station. Guys, that was just a short video on the project we are working on. Thanks you for watching.